connected, and we are live right now. Okay. Uh, Good afternoon, everyone. My name is Rendia, and this is my friend Andra and Adil.
Okay.
Right. How are you, Andra? And
I'm a little bit unwell, but surely it's pretty recovered right now. I hope that yeah, we are all better for our own health.
I see. Siapa kalau Andra? I hope you get well soon.
all right, get well soon too, Andra. Basically. Anyway, welcome to our Sunday podcast, like weekly. So we here now. Andra will be the guest, I guess. I will be the host, and Adil will be the note taker, or at least become our audience. So let's start today with Andra. Main topic is about Redox again, like last week. Andra, is that true?
Yeah, it's true.
All right. Let's delve into it. Andra, I give the mic to you, I guess. Yeah.
Okay, thank you so much, heroes. My own presentations.
Oh
Could you
God.
please see
Yes, I
the
can
title?
see it.
Yeah, I can see it well.
Means okay. Bismillahirrahmanirrahim. We start our presentations, and I hope that it will finish in on I mean on time. Okay, about the reduction and oxidations part two, right? I just wanna recall about what is the definitions of redox. Okay, redox actually stands for reduction and oxidation. As
Yes.
you can see, hold on.
Mhm.
Okay, as you can see that the reduction here means the oxygen goes down, electrons goes up.
Mhm.
However, the oxidation states or number goes down. And the oxidation is really the reverse of reduction when you
Mhm.
can see that oxygen goes up, electron goes down, and the oxidation state is increased. So when it comes to oxidation states that is decreased, it will be automatically reductions. And when it comes to the oxidations that is, uh, increase it, then it's gonna be oxidations.
I see.
All right. So this is the periodic table of the elements here. The 1A group 1A. It consists of
Okay,
lithium.
hold on. Are you changing
Yeah, that's right. The slide is
the slide?
still
Is
the.
still it's not changing. Are you sure? Uh,
Oh,
yeah,
are
it's
you
like
sure about it?
yeah. Please like
Okay. I will try it. I
okay.
will try.
Yeah, kind of want to make sure about something. Reduction means the electron decreases, right? Well,
Oh,
the oxidation is
can you
the.
see? Can you see this slide?
Oh yeah, that's it. Reduction. Oh,
Is this
reduction
the
is.
slide? Is this
Mm,
slide that you haven't seen it before?
Oh yeah. That's right.
Yeah.
So electron increases when it
mm.
comes to reduction, and otherwise with oxidation. I get it. Okay.
Right. This is
Yeah.
mm,
When it comes to the oxidation state that is decreased, it will be reduction. However, when the oxidations is up, it must be oxidations. Could you see the table?
I can I could.
Oh,
Yes,
okay.
yes, I can see it.
All right. I mean, this is the very mediocre periodic table of the elements. As you can see that the group of group 1A. A means the group because we have two groups here, A and B. I mean, B is the transition metal. You
Mm-hmm.
see that 1A consists of hydrogens, lithium, uh, sodium. In Indonesia, we say natrium, but in English, sodium,
Okay.
potassium,
Oh,
potassium in English, kalium in Indonesia, rubidium, and others.
wait, but the science of the element is still calcium. Also in America, it is potassium or
In
it changes.
America, we say potassium, yes,
Yeah, so it
but
becomes PO or what or still a K.
it's still K
Oh, it's
in
okay in
the
America.
symbol. However, when we name it in trivial name, it
Yeah.
must be potassium.
Oh yeah, I
Okay.
get it. I get it.
Yeah, like for example, like we say this. I mean, in Indonesia we say kalium hidroksida,
Okay. But in
Oh,
America,
KOH. Alright, KOH.
but in America we say potassium instead.
Oh yeah,
potassium
potassium.
hydroxide,
Oh,
Potassium hydroxide, yes.
oh,
hydroxide.
hydrox. Oh, I see.
Is it only
And
America or is it also like European way of saying
Yeah,
it?
yeah. That's also that's good
when
question.
it comes to international apa
Convention,
Okay.
penamaan men
Convention,
convention.
naming
the convention,
convention.
I mean, we say potassium.
Wait, seriously?
Yeah.
Well, why
Okay.
does it become Kalium then?
Well,
Yeah.
I don't know. Maybe kalium is the term for the Greek,
Oh, I
but when it
see.
comes
I see.
to English, it is potassium.
Potassium.
However, Indonesian prefers the Latin or Greek name. So yeah,
Oh,
it
I
turns
see.
out like we say natrium, but
Mhm.
in English it is sodium.
Oh, I see. I see.
Yeah,
Oh yeah, sodium hydroxide. Okay, got it. Okay.
sodium. Yes. And then we have group 2A that consists of beryllium, magnesium,
Hmm.
calcium, etc. And okay, we just
Skip.
ignore, yeah, or skip this group B, right? Jump to 3A, boron, aluminum, etc. Carbon, silicon, germanium, tins in 4A, and 5A, nitrogens, phosphorus,
Hmm.
arsenic, etc. 6A, oxygens, sulfur, etc. All
Hmm.
right, this is the special group. Means that all of the substance should be in a pair. For example, like fluor,
Fluorine,
chlorides, or
Cl2,
brom. Yeah,
Br2. Okay, got it.
and those are actually gas, man. So you may not see it in solid or liquid. All right. So you in the last part of group A, we have 8A. 8A here is so special, man. Special too. Not really close to 7A, but
Noble
we say
gas.
as a noble gas, yes,
Hmm.
meaning that this gas is really noble in terms of stability. So in principle, all of the elements in periodic table uh, wants to be noble gas for the electrons arrangement, something like that. Okay, we see the rules of
Okay.
redox. We see that these rules are really important because it is the way how you name the redox based on the order. Okay, so first you see you need to make sure that number one is fulfilled, and then if it's passed, then we should jump to the further numbers. Okay,
Hmm.
like
Got it.
for instance, we see if the substance is free, then it should be zero in oxidation state or number. And then if the compounds have if a compound has a hydrogen, so we need to write plus ones. And the oxygens, it is really interesting because oxygen can be divided into three ways, and mostly it is oxygens with a -2. But I will tell you how we can use the peroxides and superoxides ways. And then when it comes to the oxidation stats of natural compounds, okay, it's zero again. When it comes to the oxidation state of charged compounds, when it's charged, so we see it depends on the charge. In this way, we have -2. Okay, when the ion of oxidation state is percentage, then it also depends on its own.
Okay, got it.
Uh, yeah, we'll jump to the next. Okay, if The all six rules have been fulfilled, and we jump into the next. We should divide the substance based on the category of group. Mostly group A, as you can see that when it comes to group first A, then you can see it is plus ones, 2A plus 2, 3A plus 3, 6A plus no minus 2. I mean, group 7A is minus ones. All right, so we jump to the exercise first. All right, so this exercise will examine to you how to put the right oxidation number, like nitrogens in nitrates, sulfur in sulfates, chromium in chromates, and the astatine. What is that? Arsenic. Sorry, arsenic. Yes, arsenic in As2O5. Right.
I think the answer is going to be not. I mean, it's not difficult. I mean, it's very straightforward. I guess. O2N should be +4,
Yeah.
right?
Yes. You're right.
Yes. And then uh, the S should be +6. Adil, do you want to try it?
All right, CR2 should be plus 6 too because of it is minus 12, right? And then no, it's minus 14. O7 is, yeah, yeah. So O5 should be plus AS should be plus 5.
Ah, okay.
Okay. I
That's
mean, it's really pretty, man. Pretty easy. I mean.
okay. First,
Now.
okay. Before we continue, I want to ask, like in the group seven, in the category seven before, they are group A, 1A, right? Which is has a natrium there or sodium, perhaps, if you want to say it American way. But uh, before in the first the number one before the rules number one rules there are also natrium there. What's the difference, yeah, right, in the what's the difference between a free substance and group 1A?
All right, so yeah, it's really easy, man. I mean, I just want you to understand about the definition of free substance and non-free substance. I mean, like for example, the free substance will be presented as just an A only. All right,
Hmm.
so it stands of its ounce without any NaOH
Oh, got
or
it, without any other.
NaOP, yes, or let's say NaO, something like that.
With
So
oh, okay.
if it's an A alone or hydrogens alone,
I see.
it
So
should
it
be zero.
okay, got it. So if it's not in a compound or something, it's not, if it's not an element in the compound, it should
Uh,
be zero, it should be free substance. Okay, got it.
yeah, it should be free substance. But when it comes to the compounds which consist
Which
of several substances, then yeah, you can use the number seven rule, man.
definitely,
It's
okay,
very
got it,
easy. And
understandable.
then now we see to determine whether it is redox or whether it is a redox reaction or not. All right. So you see the Cl, man, Cl first. Okay. Uh, we need to determine the redox or oxidation number first. Okay, so it
It's
should be like this:
Minus 1.
plus one,
minus one and plus one. And
That's
what about this one?
minus 2 plus 1. So minus
minus one,
Plus one,
plus
minus,
plus
one,
one.
yeah, plus
So
1.
minus two and plus one. All right. So what about this one?
minus
So
one,
because
plus
minus
one.
1 plus 1.
So it isn't. Oh, so it wasn't actually. It was not a
Yes.
redox reaction.
No, it should be a redox reactions in
All right.
Cl.
In order to do so, I mean, so you need to examine the whether the oxidation number is increased or decreased. All
They
right.
are
So
not
let's
increase. Yeah, the
it's
hydrogens is.
HCl with uh
Oh
water. Is it increased? Yes. But what
no,
about the
No, it
no,
isn't.
no. I mean,
No, it isn't.
it isn't right. Is the
uh
oxygen is -2, the H should be +1.
actually we pinpoint the H here, the H between HCl and the H in water.
Oh, so although it is H2, we don't, divide it apart. It becomes just H, which is only one.
Yeah, it is in a compound, you know.
Uh,
It's not a free
okay.
substance.
When you confuse, then let's try number two instead. Okay.
Number two. Okay.
Yeah, number two first. Hold on.
Okay, but let's
Yeah,
see. The Cl doesn't change. The natrium doesn't change. Oxygen
okay.
definitely doesn't change, but the hydrogen doesn't change too. If you see a little bit, like the H1 is not plus two, right? It's plus one actually, right?
So you cannot see that it is increase or decrease trend.
Yeah, so it doesn't increase nor decrease.
Alright, so it is
Non
non-redox.
so it is non-redox. Yeah,
Yeah,
right?
Oh, it is just non-redox and
yeah, because
basically
natrium isn't increase or
Doesn't.
decrease, but the only increase is just HCl and water.
Are you
The
sure the
wait,
hydrogen?
the
yeah,
Velox.
the Velox of hydrogen is increasement.
Are
No,
you
no, no.
sure?
Wait,
It's not like the
did you?
oxygen is minus two and the H2 should be divided like. Let's look at the H2O. All right.
Yeah,
The
H2O.
oxygen should be minus two, right?
The oxygen minus two, yes.
And the H since it needs to recompensate, so it should be plus two, right? And then since the H
Plus one,
are
plus one.
yeah,
All right,
it's
sorry,
plus
it's
one, so it
non-redox.
doesn't change at all.
Yeah. All right, you guys are true. Okay, let's jump to the number two.
Okay, I think this is
Zero, zero. So -4 plus 4.
I think this is actually
Zero,
a redox reaction for me.
It is?
zero,
Uh,
zero.
0 0 because it is a free
Minus,
substance, and
yeah,
then minus
-4.
two and plus four.
Yeah, yeah, that's right. So it is
A
a
redox.
reduction reaction.
It's oxidation, and then the O2 will be the reduction.
Right.
Nice.
Okay. All right, so yeah, it is really redox, man.
Okay, good. Okay,
Yeah,
nice.
good.
Very nice.
Yeah, yeah. Oh, yeah, yeah. That's redox. Yeah, that's
Okay, I
right.
mean, I will erase first. I mean, I have difficulty to see it when it comes to messed up. Ah, okay. What is about it?
Mangan is zero, of course. Wait, is it? Yeah, that's right. It's not mangan. It's magnesium, right?
Yeah, mangan is like this actually.
Yeah, Mn is mangan, right? But
Yeah,
Mg should be magnesium.
magnesium. What about it?
So it is. Wait, what will happen if there is two?
All right,
Yeah.
two has nothing to do.
Oh, nothing to do. I see. So +1 and -1,
That's right.
Very
That's right.
nice.
It's really good. It's really good.
and Cl should be um. Wait,
Minus two again.
Yeah,
wait. How can it be -2?
it is
The
because uh, yeah, and yeah,
Yeah, because it is not, first of all, it is in
Oh,
categories
7A.
7A, and then it
Yeah,
should
that's right.
be, and then it combines
-1.
with, yeah, that's true.
It should be -1, not -2 then,
Yeah, yeah, I guess,
right?
yeah,
Should be
oh
minus
yeah, yeah, yeah,
one.
you are
should be
true.
minus one.
And finally, H2 will be 0.
All right, I will
That's
erase
true.
first.
Hmm. That's correct.
Okay,
I do.
like this.
Yeah.
Oh, okay, all right. So how could you make an arrow?
Magnesium is a reduction and wait, yep, reduction and it is oxidation.
Okay, so basically it is approved as redox reactions. All right, that's true. And we jump to the last questions here. So what about the reactions between magnesium sulfates plus salt resulting
Uh,
natrium sulfate and magnesium chloride. Sorry, sodium sulfate and magnesium chloride.
Oh man,
so
this is. Let's just skip and then tell that we know that from number two, we know that SO4 is actually like minus two, I guess. Right? Correct?
yeah,
SO4. That's
SO4 is, yeah, that's
the whole
minus
compound is
two.
minus two. Is it
Yeah,
not?
that's
Uh, Actually, when
step
we
by step, isn't it?
Okay,
like
let's
this,
just watch step by step. All right. Okay, minus.
okay,
So the O will be minus two, and then O will be minus eight, and then this S
Mg
Mg
should
should
be
be
like this.
mine plus two. Mg should be plus two.
yeah plus two, and
And
hey wait
so
plus two.
sulfur,
Yeah, Mg
yeah,
should be plus six, right?
Mg should, no, Mg is plus two while sulfur is plus six, because in rows number seven, group 2A, Mg is plus two.
Okay, so
Okay, I think that.
Mg is plus two,
Yeah,
and
plus
then S
two.
plus six. You're
Yeah,
plus.
I think that's this is the correct answer, but please let me know if I'm wrong.
Hmm.
Okay.
All
We
right,
we
maybe you are correct actually. I did.
we
I
will
think
name
you
it
are.
first. All right. Let's jump to the salt.
I think it is minus. I don't know. I see it like a plus two.
Okay, so it's
Oh,
minus.
yeah, all four should be plus minus two. Anyway,
NaCl should be minus one plus one.
Okay.
yeah. Plus one and minus one.
Mhm.
Yeah, that's right.
And then
And then, wait, this isn't a redox reaction, isn't it?
yeah,
Uh,
minus
let
two and plus two plus one.
let me
Yeah, I don't. Yeah,
clarify it.
minus two minus eight. S should be plus six, and then the natrium should be plus two.
Plus one.
Plus one,
Plus
yeah,
one.
plus one, and yeah, it recompensate the plus the leftover of minus two from the SO4. Yeah,
Yeah,
plus six then.
yeah, yeah, plus six.
Plus six.
Yeah,
Yeah.
it wasn't redox reaction.
Okay.
It isn't, not wasn't.
Yeah,
It
not yeah,
isn't.
it isn't redox reaction. It is not a redox.
So it's like this, right?
Yeah.
Yeah. No. Plus two. Mg is plus two.
Oh yeah, Mg plus two. Sorry,
Okay.
Cl is.
All right. All
All
right.
right. All right.
Let's us examine it. Okay, as you can see that the magnesium's oxidation state uh, does not change. So does natrium's or sodium's oxidation state. So we can examine it as non-redox.
Mm,
Yeah, you are very true, man. All right, let's determine the reductions and oxidations as well as oxidator and reductor from these reactions.
All right. Cu should be, what is it? Um, wait. There is no Cu in here.
it's copper.
Yeah, but
Mm.
no rules.
Well, I
Cu.
mean,
What
we
group
can
is
use
that?
the rules of this.
And no, there's no Cu in the rule, so I don't know.
When
Then
it
let's
comes
just use S, I guess.
no rule, then we can use as first
Plus
as it is
Oh,
scattered
six.
plus
in the
six.
group.
Oh no, S should be minus two
Okay,
because it is
minus
group 6A. Yeah,
minus
it
two
is
plus
in group
two,
6A.
and O3 should be
Yeah, you are very true.
Uh,
plus
plus
six,
one.
plus
No, oh,
five,
yeah. No, yes, plus
five.
five. That's right. That's
Now
right.
you see, it is an ion. I mean, a charged
So plus two.
an ion.
So this is
So
plus
It's
two,
very great.
two minus two,
and minus two.
and
But this
then
isn't Oh no no no. Right, minus two,
The
and then
-2 for the
minus two
oxygen,
and
and
plus
then +2.
two. Wait, there is no oxidation. No no, there's no reduction here. Or I'm wrong. Yeah,
Okay, let's
Then
see it.
next, okay, good.
there's
I
no
don't,
reduction.
I do not, yeah, yeah. I don't know what the hell happened.
Yeah,
Okay,
only
I'm wrong. I'm wrong.
nitrogen.
There's no two means. There's no two means.
Oh, no, two means
Oh,
zero
it's zero.
zero.
All right, got it.
I see, I see. It makes me confused there.
So S will turn to zero.
Yeah. So I guess the oxidation happens with uh with natri no, no, it's not natrium, it's
So
nitrogen.
from the oxidation, right? From the
Yeah,
Yeah,
no
sulfur
yeah,
to
no.
it's
the
true.
I think it is reduction. Sulfur is reduction.
So for
no,
actually,
the Bilox is increased, so it is as oxidation, no?
No, reduction is electron increases.
Yeah, but this +2 or this -2 is refers to the Bilox oxidation state rather than electron.
Oh, so it is different. Oh ya, bilangan oksidasi ya. Oh iya benar
Yeah,
juga.
yeah,
but
yeah.
Yeah, yeah, that's right.
From -2 to zero, man.
Oh yeah, yeah, that's right. So I'm wrong all 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 along. I have wrong. I have
oxidation,
wrong.
Yeah, it's
and
okay,
Oh
man.
then the natrium will be the reduction. But it is sulfur. It is an oxidator.
oh yeah, yeah, yeah. So sulfur is the
Reductor. Sorry.
reductor, and
Yeah,
nitrogen is the oxidator.
that's I think that's true.
What is the oxidator, man?
Oxidator is reduction, while
Yeah,
reductor
very,
is
very
oxidation. That's very hard to remember.
true. Yeah,
Yeah, you
because
know.
uh these nitrates makes cuprum sulfate to become oxidation. So yeah, that's why we see this particle makes this particle to be oxidized.
I see. I see.
All right, so I'm wrong. It's not NO3. So the reductor, uh, eh, the
The oxidator
the oxidator
is
will be.
the natrium itself, right?
It's true. Yes, yes, it's true. Sorry, sorry.
Wait, why
Wait,
they
wait. How
are
about NO?
why
How about
oxygen?
What?
Why the oxygen is included? I thought it was only natrium.
yeah? I mean, if the oxygen is included, then there should be
Okay,
NO.
let me clarify. Uh, okay, there is a misunderstanding here.
Mm-hmm.
Okay, look. When I say the oxidator,
Yeah.
the oxidator is the one that drives other uh, compound to be oxidized. And what is that?
It's
It is NO3, right? NO3 minus. Because
okay.
NO3 minus makes COS to be oxidized.
True. I believe that. I believe that's correct. But is it the whole compound or is it the
Element.
element in the compound that should be
Well,
noted?
actually, when we refer to the oxidator,
Hmm?
we should include the all compounds
Before the
or
reaction.
before the reactions, yes, because
Okay.
before the reactions or the reactions, the left side of reactions is the reactions, man. So the reaction will produce
Result.
the product. Yeah, you are very
Yeah.
true.
Hmm.
Oh, I get it. I get it.
Yeah,
Yeah, yeah. I get it.
So
So
the
oxidator.
yeah.
Okay, okay. Randia, you go.
Okay, so the oxidator should be the NO3 and the reductor should be the copper sulfide, the copper
yeah. You,
sulfur compound.
the reductor
Choose.
will be COS. Yes.
Ah, okay, got it.
CUS.
Understandable. Yes.
Cuprum sulfur.
Actually, sulfate,
Cuprum.
sulfate
Sulfite.
because uh,
Sulfite.
Sulfates.
yeah, sulfate, yes. Because when we say sulfate, it should supposed to be like this, man.
Hmm.
CuSO4
Oh,
sulfate. But
CuSO4.
when it comes to CuS, it's cuprum sulfide.
Oh, I see. All right, next problem.
Okay.
uh,
O3 minus 6 and then plus 6.
minus
Cl,
6.
the
Oh yeah,
chloride.
plus 6. That's right. And
Eh,
then this one is plus 6, and the calcium will be.
are
Wait,
you sure it's
is it?
plus 6? I
I
think
think it
just
is
minus
plus
1.
1. Yeah, yeah, that's right. So minus 1 and
Plus 1.
no, no, plus 1 and minus 1. The calcium should be plus 1, while the chlorine should be
Minus 1.
minus 1. That's right.
Mm-hmm.
H2 is plus 1, so it becomes, yeah, that's right.
So
So 6 plus 6
it's
plus
plus
6 sulfur.
6.
So
So
sulfur is
the H is
the
should
plus,
be plus 1.
yeah. I mean, it's kind of trivial, to write down the hydrogen or oxygen because they always
Hmm.
plus 1 or either plus minus 2. So yeah. So the
The
calcium should be,
Yeah, we can see from this table actually. Hydrogen is prioritized and oxygen is prioritized. So yeah.
yeah, that's right. It's kind of trivial to write down the blocks,
Uh,
the second one.
but that's fine.
Look, I might be wrong here, but the sulfur oxide could be ultimately be give some Belox number such that is minus 2, and immediately the whole
okay, okay.
compound of SO4 is going to be minus 4 and minus 2, and then the calcium should be, yeah, and then we can deduce that calcium is plus 1.
Something like this.
Yeah, instead of the
Oh,
calculating the whole oxygen and the sulfur.
that's how you do it when you were a high school student then?
I think probably yeah, since it's kind
I
of
never, yeah, I never did something like that. It is always, one by
one
one.
by one. I see, but it's kind of like a pattern. There are pattern to such
Yeah,
compound.
that's right. Yeah, you are right. I should follow your uh pattern.
They, I
What
So
guess,
about chloride, man?
0, 0.
0 0
And finally, I think it
plus
is,
plus
we
one
don't
minus
really
one.
need to do anything about this because,
Oh, sorry, plus one. Sorry, plus one minus two. Yeah, yeah. Hydrogen should be plus one.
so the chlorine is become a reductor and oxidator in this case.
Chlorine is
The compound, which compound?
Yeah,
Remember?
it becomes both reductor and oxidator.
Oh yeah, I guess so. The plus 6 into the 0, and then
It becomes reduction, which is an oxidator, ClO3.
yeah, I mean, oh yeah, that's true. The Cl,
what's the oxidation, man?
Yeah, it's
the
reduction.
Cl in the KCl, I guess. That is the oxidation.
And the potassium chlorine,
Mm,
it should be oxidation
mm.
reaction.
Here.
No, 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 no. The chlorine.
The chlorine,
The
but
chlorine.
the
Okay,
oxy.
okay.
Wait, you should erase it, man.
Control Z
Yeah, that's right. Control
Control
Z.
Z. Actually
doesn't work.
doesn't function.
Okay, okay, then you
No.
should erase it the normal way.
Yeah, Cl. All right.
This is offhanded, but I tried this in the latex. It's hard.
Oh, wait. You ever tried something like this, friend?
Yeah, the arrow is really hard. You need to install some package in latex. So
Oh, yeah. Latex is.
offer me find this.
Yeah, I know.
Okay. Yeah, that's
Over.
mm,
Yeah.
So that's what
You have to, you you know, so we can make a nice arrow.
arrow. Mm.
Yeah,
But continue, Andra. So that's what happens, right?
Yeah, that is what happened actually. And then we can see that KCl actually is increased, right, in the oxidation number
yeah,
Yes.
that's right.
because it is increased from -1 to 0.
So there is oxidation, and then the whole compound of KCl in the is the reductor.
It's the reductions. Yeah, exactly. Okay, let's jump to the. All right, we actually face the new sections of Biologs. As we can see that I already told you that the oxygens here in number three can be divided into several oxidation states. The first, you see, oxygen can be -2, but when it comes to peroxides and superoxidates, they will be -1 and minus a half, respectively.
Okay.
So it relates with this. It associates with this. All right. So in peroxides, we see that the oxygen oxidation number will be like this.
So we don't change the huh?
Sorry.
It's just plus one with minus one each, right?
Minus one. Yeah, -1,
Mm,
and it will
plus
be
one.
+1.
Got it.
Yeah. So the difference is that oxygen has -1 in peroxides instead of -2. And we can see that the oxygen here is -1, but in superoxides, I mean, it will be minus a half. It is because superoxides, okay,
Okay,
and the
this
number
plus
of
one.
sodium will be +1. It stayed on +1, so it becomes a superoxide.
How could we know?
Yeah, I mean, it is the example of how we name some, barium BAO. I mean BAO for different oxidation number. We see in the first that when it comes to the oxidations number of uh, oxygens, I mean, it has -2, so it is actually uh, really oxide
I think
oxygen. Sorry,
barium oxide, barium peroxide, barium superoxide.
but peroxide and superoxide have -1 and minus a half. Yeah,
Oh.
it is stated like this.
Hey, do does peroxide and sorry, does superoxide only happens with group 2A, or is it could be in another group such as 1A? Like, for example, like if we have H4O4, will it be considered as superoxide, or maybe should it exist?
Sorry, can't you please
So
speak
this is
apa
barium, right?
reply?
Barium should be
Yes,
plus two because it's in the group 2A, right?
group two. Yes,
Yeah,
you are
group
right.
2A.
Uh,
Yeah, and exactly like the oxygen -2, it should be if it's just a normal barium oxide, it should be just the oxide it should be -2, but it is we force another oxygen in there, so it will become barium peroxide and so on. We force another oxygen, and so it becomes superoxide. I think this is happens with the group 2A only, or is it could be extended to group 1A, which is, for example, like hydrogen for like H4O4.
Yeah,
Uh,
interesting.
Hmm.
I mean that it happens to. What about sodium?
Yeah, and
Sodium
that's
is
it's
group
group
one
2A,
A,
right?
right?
Oh, is it? Yeah, yeah. I guess yeah, that's true. It's 1A. Oh yeah, that's
Yeah, it
happens. So it is it does. It could happen.
happens to group one A too. I
All
mean,
right.
All right.
when you saw the barium with the O4,
Mm-hmm.
then you should think automatically it is superoxides.
Oh, okay.
But when it comes to BaO2, so you
It is
should put
peroxide.
-1. It is because it is peroxide. Yes. So it depends on the you know the substance behind. Sorry. Left in the oxygen.
Got it.
And then I want to tell you about the hybrid compounds here. The hybrid compounds consists of metal plus hydrogens.
Oh man, this is actually tough because the both calcium and hydrogen is both on the group 1A, right?
Sorry.
Um.
The potassium and hydrogen both in the group 1A.
Yeah, yeah, it is in group 1A along with lithium, sodium,
Yeah,
and
but we assign hydrogen as the -1 as a Bilox.
Yeah, I guess.
yeah,
You know what, guys? I guess some part of this redox will use memory. Like
Right, right. But
there are cases where this is yeah, special cases like this one, right?
yeah, the hydrogen
yeah.
isn't.
So memorizing is important sometimes.
like in this case, in this case.
All right, this is okay. I see, I see. Yeah, it
So
is memory.
when it comes to metal plus hydrogen, then you automatically should put -1 as a block for hydrogens, like calciums and hydrogens.
Mm-hmm.
You see that calcium is a metal,
Mm-hmm.
yeah, metal because you see that uh, in this region, you can uh, you can call it group 2A as alkaline earth,
Mm-hmm.
and the group 1A as alkali metals. Alright,
Oh,
both of them are metal.
oh, I see. Both of them
So
are
if they are
metals.
metal, what compounds are non-metal? Non-metal is here, man. It is presented by the color blue, like
It is.
carbon, nitrogens, oxygens, phosphorus, sulfur, and selenium.
Mm.
Oh,
But it is interesting that hydrogen isn't a metal, considering it is in the group 1A. Maybe that has the lowest
Yeah, yeah, as
electron.
well as hydrogen.
Yeah,
Yeah, true. Yes.
I get. Okay, got it.
oh, yeah, yeah, yeah,
Yeah, yeah, yeah.
Hybrid potassium. Does it call hybrid potassium?
Yeah, I mean in Indonesia we say kalium hybrid, but when I
Oh,
yeah.
hybrid.
translate it is hybrid potassium.
That is interesting.
Halogen, yeah. When it comes
Okay.
to halogen, it is in group 7A. So why is it always in the pair? Okay. So as you can see, ah, for example, like you know, it's supposed like this. Uh, F. Okay. This F has seven. Yeah,
-1. Yeah, 7 electron.
7 electrons.
Okay.
Okay. In order to be stable, he needs one more left.
Hmm.
uh One more
So
electron to, you know,
when he meets another fluoro, they will make the uh oh
bond.
I mean,
Bond.
my drawing is really worse.
Okay. Yeah,
My
yeah.
drawing is really worse. All
Yeah,
right, no,
they will
that's
be
fine.
bond.
That's fine.
Yeah, I
Like
mean,
chemical bond, right?
Hmm.
Like hydrogen bond.
yeah,
Mm,
it creates the chemical bond.
yeah.
Yeah, something like that. It becomes a bond as they share the stability of 8 electrons.
Oh, I see. I see. I see.
So it needs like two. I mean, I know this is diagram, but there are for each side of up, down, left, right. There should be two.
Yeah, yeah, yeah.
Uh,
You're very true.
for create to
When
create
if fluoro has no pair, it becomes like this. Uh,
minus one,
minus one. Yes.
one minus.
One minus
Since it
F.
is F minus.
F
Okay,
F minus. It's very low in score.
but yeah, I guess
No,
that's
no, no. I mean, F plus, right? Because of when it is it is more
what?
it is less electrons, then it should be plus.
Huh?
Oh
Should it
no,
be
it's not.
minus? Because I know oxygen is minus two.
Uh,
Yeah, I think it's. I don't know why. I think it should be minus.
Yeah,
Yeah,
I think it's
I don't
minus.
know. I don't know. So, but let me check if I'm wrong. Let me know
Hmm.
if I'm wrong.
I'm gonna check it myself.
all right. I will take it through the Google too.
F minus chemical
It's
F.
minus actually.
Yeah.
Minus right there. Minus rand.
It's minus. Yeah, F
Oh,
minus. This
F
is F
minus, right?
minus.
Okay.
Yeah, you know, like oxygen is minus two, fluorine should be minus one, and then the noble gas plus or zero actually minus zero.
Yeah, because noble gas is already stable. In other words.
Yeah, it's kind of logical to
It's
see.
kind of, yeah,
All right. Okay.
makes sense.
So
Yeah,
okay. Here you see that when we use one of the halogen substances, for example, chlorides,
yeah.
when the chloride stands for its own, it should be zero in Velox.
Okay.
Okay,
Yeah, we were right.
but
We agree.
the Velox, I mean, the oxidation states of chlorides can be changed as uh, the entire substance differ to.
True.
Entire substance. Yeah, yeah, yeah. That's right.
We can
You know,
all
it's like,
Yeah, we can always deduce it. Yeah, right, Adil?
I mean, when the element is in the middle, like calcium, chlorine, oxygen, it must be the chlorine somehow who will become, we will has reduction or oxidation.
Hmm.
Yeah, I kind of remember it from my high school back then.
Okay, okay. When the element in the middle, so it can be reduction or oxidation, something like that.
Yeah, yeah, that's what I remember
The
from.
Bilox could change based on
Yeah, the bill.
Okay.
Yeah, it's usually the
the
middle
middle
element
element.
who will
So
be the,
the middle is unfixed.
yeah, the target. Yeah, that's right. The unfixed.
Oh my.
That's right. That's right.
All right.
What
Now,
warning? What?
no, we should. Ah, no. I mean, uh, I'm really afraid if the time is up.
Yeah, it's about 4 minutes left,
Yeah,
but
but I will.
No,
I
no,
will.
not 4 minutes left. I guess until Ashar. You know.
surely. Okay, maybe just add 10 minutes, I guess. But uh,
Okay. So
let's
do
be
you
quick.
mind to add 10 minutes as an extra?
Sure,
Yeah, yeah,
why
yeah,
not?
yeah. Sure enough.
Okay. Okay. So this is the half reaction method.
Half
And
reaction
it
method.
is
Yeah.
because, it is the reason why I learned Velox, since we need to complete the half reactions method in order to uh yeah to pass these electrochemistry lessons. And
Uh,
the first rule is you need to determine both oxidation and reductions reactions in a reactions. And then after that, you need to calculate the charge. I mean, like muatan in Indonesian,
Yes.
and also put either hydrogens or a hydroxides in the reactions depending on the conditions, whether it is acid or base. After that, balance it.
Hmm.
Nah, this is the warning. Acids, when it comes to acids, you need to age
oh yeah, I
with
remember.
a
Yeah,
room
this
where
is
it is less started.
I think this is the hardest chemistry stuff when I were in high school. The
Yeah,
teacher.
many student fails at the time.
Yeah, I even learned this from my cram school instead of my school because
Cram school.
yeah, NF bimbel. What's bimbel? Yeah, that's
crime
All right,
this is
no
school.
very
people.
hard. This is very hard. Okay, go on, continue.
Continue, continue.
Best, when it comes to best, add hydroxides in a room where it is more started. All right. Okay. So the first we need to determine the oxidation and reduction first, man.
All right, ready? Go.
What do you think? Am I a Pokemon? Yeah, plus six. Sorry, yeah, minus two plus minus six plus six and then plus three.
Is it plus?
Yeah, I
Yeah,
guess
plus.
plus three. And then minus two and then plus one. Yeah, right. I mean minus six plus six.
No, no. That's
Sorry, plus
minus.
five, plus five, plus five. I forgot. I didn't see the minus there. Right, right. And then this is minus one. Yeah.
Minus one. All right. Let me check the master because I'm afraid when it it is failed, then we face the failure afterwards.
Okay,
Yeah,
okay.
I
Recheck.
understand. I still remember. I still remember.
Minus two, minus
And then
three.
so Bi will become the oxidation while Cl become the reduction.
Yeah.
And
Okay,
this
so
is
what? Sorry. The
uh
BIO B
Bi is
A
Bi is
the
oxidation.
or the reductor, the whole compound
Yeah,
oxidation.
and Cl will
L
be the
is
reduction.
reduction.
All right,
Yeah.
so we see that we got the oxidator and the reductor. All right, so uh, keep keep in mind that the condition is acids, meaning asam. So it is slightly different when it comes to base. All right, so we need to add H plus later in the site that is less charged.
Oh, this is after reaction or before reaction? That
Yeah, we are gonna divide it into uh two sides. Okay, the
oh,
first is oxidation.
okay, got it, got it.
Oh yeah. This is the half reaction method. There's the second method, isn't it? I kind of forget the name.
Yeah, this is like a half reaction method, man. So you see that the oxidations has Be2
And
Uh huh.
O3,
O3
yeah, yeah,
and
to
Be
the Be1.
Oh yeah, that's right.
BeO3 min. Yes.
So we add H, right?
S. Okay. You need to add all right. So
Hydrogen there.
you see here
We
Be
have to.
in the right side is less.
There are
Yeah.
So
minus charge,
it
so
needs
we add H.
to add two first in order to balance it between Be2 and
Oh yeah,
Oh,
that's
okay,
right.
got it.
I
Yeah, man,
remember.
this
I
is.
remember.
Oh God, this is. Yeah, I guess this is the hardest part of chemistry. I don't want that. Really don't want to remember it.
Yeah. And then we kind of have to do it the same from ClO minus,
Yeah.
yeah.
right?
But
After,
there is something wrong about it. So
yeah, the O3
uh,
is not.
the O3 three is excessively
excess.
compared to the left side.
So the
So
three.
so we need to add H2O here
Oh my
Oh,
god.
because
and we have to.
it is it is contains sorry, because it is contains six.
So we need three
Yeah,
H2O.
three H2O. That's right.
Oh my god.
It's like nostalgia, man. Nostalgic, because yeah, I used to have this
Is it
ulangan.
balanced?
Yeah, it's balanced right now. It should have
But
balance right
what's
now.
more? What's more?
The
ClO.
the hydrogen in the after reaction
Yeah,
should
you
be
are very true.
should be six.
Oh,
God
that's how we
damn.
do it.
So we have this the balance between hydrogens and oxygens as well as Be.
True.
All right. Now it is
All right. So the
uh
next step that we need to do is
Reduction.
uh, we need
Cl.
we need to calculate the charge like this.
Hmm?
Does it contain charge? No.
No.
Does it contain charge? No.
Yeah, no. And then
Does
this
it
is
contain charge?
minus two.
Yes, minus.
Minus
Minus.
No, minus one.
minus one, okay. But they are two, right?
I don't know.
Okay, it doesn't matter actually. Yeah, just minus. And then plus.
Well, actually, it matters.
Oh,
It
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 does
is
matter.
minus two.
It is minus two.
Oh, minus two. I see.
It is minus two because we have coefficient. So the coefficient is calculated
Oh, I
on
see. I
this.
get it. I
Now we
understand.
calculate.
So it is
Plus two.
plus six. Plus six.
Plus six. I know this is an acid because the 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 the, the plus one is bigger than the minus sign.
Yeah, and we
Plus four.
calculated first. Yes. So it differs atau selisih 4.
Yeah, the difference
Uh,
is four.
oh no, we have to erase something for
Uh,
the CL.
We need to add for
Oh yeah, yeah, for
like that in order
electron.
to make it uh,
compensate.
same
Even
zero. Yeah.
even even equal.
Okay.
Next is CL.
Okay, next is the reductor.
Next is the reductor. Okay.
Reduction. Sorry, reduction, not reductor. How
Oh,
confused.
reductor. Yes. Reduction. Yeah.
Reduction. The Cl2, ClO, and Cl.
This is really really the funniest part. I mean, okay.
Funniest part?
Funniest part?
The funniest part.
What
Yes.
part of this is funny?
All right. So there is something wrong about it. First, what's wrong
Alright.
about it?
Yeah, we have to make it even.
The
We have
oxygen,
to multiply it with. Wait,
there are no oxygen.
Yes. Yes. You are very true. And because of there's no oxygen here, then what would she do?
at H2O.
H2 or HO or OH, I don't know. Okay,
H2O,
H2O
H2O.
first. Okay, guys now. Guys, yes, okay.
And then we have to add H in the left side.
On the left side,
To
How much
H. To
hydrogen?
H. Two,
two.
two, two.
All right. Okay. Because of it's already equal, then we should calculate the charge.
Electron.
Plus
Yeah.
two, minus one. My
Minus
God, minus
one.
one.
No.
All right. Then we need to calculate it again.
The difference should be
Minus
two, I guess.
plus one.
Plus one, minus
And then this
one.
one is minus one. And what should we do with that? Or two, two, two. Oh yeah, I see.
Between one
Oh
and
yeah, two, two,
Minus two.
two.
Okay, two. Okay.
all right. So because of you know it has four electrons in oxidation reactions, and because it is two electrons in the reductions, but we haven't added the
Yeah.
electron here in reductions. So what side we should add two electron?
in
It happened
the left
at
side. In the left side.
left side.
Or is it
Is
wrong?
it is it the right side? I don't know, man. I'm not good
Oh,
at
it is to
chemistry.
electron because we need to neutralize the acid here.
Okay,
Oh
this is the
yeah.
Made
left.
by hydrogen.
So
Alright.
what about the other two electrons?
Okay, so what we should do is
Oh, I remember what will happen next. We have to multiply the Cl part, right, the reaction by two. So then we can, cancel out the
Oh
electron.
my
yeah, yeah.
god. Okay, got it. The whole reaction is times two. I see. I see.
But I kind of forget after uh we cancel it out. Does
All
we?
right.
For E
So the first it will be reductions for E
plus 4H plus 4H plus.
to H plus
Huh? You time you don't time it too,
4.
right? Four, right?
Yeah, yeah. You have to time it too. Two Cl,
For yeah, 2Cl and
two
then
Cl
2Cl
O
minus
min or minus.
plus 2H2O.
Two Cl minus, two Cl minus, and two H2O.
Yeah.
Two H2O, bro.
Oh, okay, okay, yeah, you are very true.
When I skip almost half or more chemistry question in SBMPTN.
No, I must do every question in the chemistry. SBMPTN.
I'll skip them.
Well,
Okay, continue.
this I mean I will say that this chemistry matters when it comes to BUMN requirement because
Oh,
you need to attest you need to be attested in chemistry, physics, as well as the English.
like in
Oh,
Pertamina?
Yes, in Pertamina.
Alright, right. Okay.
So I mean, it might be useful someday,
So,
maybe.
someday.
well, I wish I was. Okay, okay. First continue. 32L BI O2 L3 BI2 O3, and then it turns to freaking 2 BI O3. Man, this
I
is
don't
tough
know.
as hell. Okay. While Andrea continue can we do reduction first and then oxidation rather than the
Yeah, I mean,
oxidation
it doesn't
first?
matter.
Oh, it doesn't
You
matter.
can
Doesn't matter. Yeah,
you
yeah,
can
that's
proceed.
right.
All right. So we need to
We
cancel it as Adil first for E with for E.
and then the H we also cancel it, right? The hydrogen,
The hydrogen here
so it becomes uh 2H plus in the right side.
become 2H.
Yeah, yeah,
Yeah,
right.
yeah,
I don't
yeah,
know.
yeah. We can reduce. We can delete it, I guess,
Yeah, it's
or
like
remove
a
it.
mathematics calculation,
Yeah, yeah. Oh my god.
Then H2O with uh the H2O parts we cancel it. Yeah, yeah,
This
that's
is
right.
this is a lecture rather than podcast. God. Well, okay, but it is cool, I guess. Continue. And then
So the result will be H2O.
H2O plus BiO3
Yeah,
and then
that's
plus
right.
2Cl
2ClO minus.
minus equals to results in 2BO3 2BiO3 and then 2Cl basically
Yeah, yeah. You already got it, man.
plus
It's true.
2H
Yeah,
plus.
yeah, yeah, that's right. Yeah, I think we understand what
Here we
will
go.
be
Yeah.
the result
So that is
for
an
Yeah, I
acid.
mean,
oxidation.
yeah, but our time is
Yeah, yeah, you get it.
up, man. Okay, sorry.
I
I'm
think
bad in managing time, so yeah,
nah,
sorry.
it's
So
fine. I mean,
we
but we
we
get it.
haven't
But we get
aiming
it.
Yeah, I
we
think
The
haven't
we
aimed
get it.
the goal yet. But my goal is to teach about the half reactions and the oxidation number method for reaction, but without charge. But
oh man,
actually, it failed.
All right, all right.
Yeah, we can continue
Continue it
it
later.
for the next meeting.
Yeah,
Sorry
But
for
yeah.
taking your extra time.
okay, let me summarize it for you guys. Like, today we review one of the redox reaction from our previous podcast from Andra about redox, and then we try to some new things, some new cool things that we learn is about super like an oxide, right? I mean, peroxide and superoxide, and then after that we learn about half reaction basically. That's I think that's new things, the big things that we learned today. Right, Adil. Adil, do you want to add something, or Andra
Yeah,
maybe?
I mean, like we went back to high school.
Yeah, yeah. I'm not
High
particularly
school time.
good at chemistry,
Yeah,
but this is nostalgia for me in high
yeah,
school.
nostalgic. I really remember. I think I got scores like 80 in this
Subject?
chapter, yeah, in this subject around
80.
80. I kind of forgot about it. Yeah, it was quite confusing back then.
Hmm,
Yeah,
Very
thanks
very
God.
confusing.
Ren, we had a good teacher, right, in chemistry.
I guess so.
Coincidentally,
I guess
Miss
so.
Alicia.
But yeah, I don't exactly. I mean, she is a good teacher, but I
Ren, Adil, our own chemistry teacher actually had ranked it as the winner of the chemistry competition for teachers for a province.
wait
What?
there exists such
Wait,
competition.
hold on. So this chemistry teachers of yours is kind of a great teacher where she won award
Yes,
for the best
where,
teacher
where
or for
she won the chemistry competition for teachers.
oh chemistry competition. It's
Yes,
not best teacher but competition like Olympic competition.
yeah, Olympic for teacher. But
Oh, there's such a
so,
competition.
so that she actually teach in chemistry properly, according to my opinions.
I
Oh,
don't
I
really. Mm.
see. Oh, there is that kind of competition.
Yeah, I just okay.
It should be for the student, right? I mean,
Yeah, because
yeah.
maybe the Department of Educations need to need to examine the teachers in the state or public schools. So yeah, they do the examination for teachers only to see how far the teacher understands
Oh,
about the subject they they teach.
I see. Is this teacher is the reason you choose chemistry as your major, Andra, because she inspires you, or what?
Uh, Actually, she she had nothing to do with that, but
Oh,
Okay.
because of her lessons, I understood a lot about chemistry.
Hmm.
oh, I see. I thought she is your inspiration. She is your idols when it comes to chemistry, and
But idol.
you want to follow her path.
Oh, okay, okay.
uh,
Uh,
no, no.
Actually, I just utilize her lessons,
Uh,
listen only. I mean, her listen is simple and understandable. So yeah, I could easily understand about the chemical stuff.
I see, I see. So you just appreciate her for what she had gives to you. She had
Yeah,
given to you. Oh, I see.
that actually true, man.
Yeah.
Yeah,
Yeah, I don't want to say many stuff about the teacher in my school. I'm afraid. Yeah, just yeah, she's good, and I don't really want. Yeah, yeah. I guess for my teacher, that's it. I guess.
Hmm.
Yeah.
Okay. I see. So should we end this podcast, guys? I
yeah,
guess.
yeah,
All
yeah.
right.
We
Yeah. All
can
right.
do that.
Sure. Okay. So thank you all for joining in this podcast. We talk about redox today with Andra and we basically this is more kind of akin like lecture about high school stuff, but it is pretty much interesting for me because we learn something anyway. Yeah, so this is just a free talk between us three. I guess I think that's enough for us for today. It's already past 10 minutes from 1 hour podcast, perhaps. Yeah, but literally, thank you for joining in, and I'll see you guys in the next week with Adil as a guest, right? Adil,
Yeah, I should be the guest next week.
do you have
Yeah.
topics? No,
I
or do
think
you want to
it
keep
will
it simple?
be conflict resolution
Two
no, 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 I
application.
mean like we implement it, we
I
train
see.
it.
Oh, so should we have practice in the
Yeah,
next?
I mean like I'm going to be mad at you and you have somehow to resolve it in the best way possible.
All right,
Yeah.
all
Mm,
right.
okay.
Okay. That is so. That's the teaser for the next week. Thank you all for joining in, and I'll see you guys in the next week. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi